Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, Doktor.
Okay, we are here to continue flexibility method. This is frame analysis. Okay, frame will have similar analysis with beam because we will integrate moment equation in order to calculate displacement. Previously, we have done beam analysis. One redundant, two redundant. Okay, please watch. If you don't enter the class, please watch the recording. Okay, because you need actually to watch all the class session, whether it is face to face. Also, I make recording or an online session. You have to watch all the recording because in every session I normally do different question. Okay, so this morning I have discussed one frame example, one redundant, and I extend to two redundant. Okay, so now we move to this one, 5 unknown reaction, and two redundant. Okay, 5 unknown reaction and two redundant means that we have to we have to have two equation called compatibility equation, which we transform to matrix form. Standard compatibility equation, we use metric form for 2 and 3 redundant. Okay, so as I mentioned previously, in flexibility method, what most important is we know the goal. We know what is the final outcome, what is the objective. Okay, we know that the objective is to calculate a reaction. Flexibility method is a method to calculate reaction in indeterminate structure, and we have to use flexibility method whenever 3 equilibrium equation is not enough to calculate reaction. Okay, because we can only solve 3 by using equilibrium equation. So now we have 2 redundant, and redundant is the problem. So the final aim is the three reaction. But before we can get the 3 reaction, we have to solve the problem. The problem is the redundant. Okay, the problem is the redundant means that if we can calculate the 2 redundant in this frame, we should be able to calculate remaining 3 unknown reaction. And the 2 redundant can be determined using compatibility equation, which is based on displacement at redundant position, displacement. And inside the displacement formula, we know that displacement, we have to integrate moment equation, two moment equation, in order to calculate displacement. And inside the formula, there are moment equation. And moment equation we get from primary system and redundant system. Okay, and moment equation, and to get moment equation, we have to have reaction. Okay, means that in flexibility method, this is actually application to what you have learned previously. You have learned how to calculate reaction in determinate structures. You have learned how to write moment equation in determinate beam and frames. You have learned how to calculate displacement, deflection using unit load method. So we combine all these in flexibility method. Okay, so we will analyze determinate structures, not one structure, but it depends on redundant. If we have one redundant, we have two system, two structures, two determinate structures. If we have three redundant, we have two redundant, we have three structures to be determined, to be analyzed. Okay, so that's the idea about flexibility method. So we will start with Okay. First step. What is the first step? What is the first step? Okay, we have to calculate
DOI.
your simple formula. It is just the difference between 5 unknown reaction and 5 and 5 and 3. 5 and 3, right? The difference. Okay, it is equal to 2. Okay, it is equal to 2. Okay, so from this, we know that we have to remove 2. From 5, we have to remove 2. Okay, we have to remove 2 redundant. We have to remove 2 redundant. Okay, remove 2 redundant from actual frame. We have to remove 2 redundant from actual frame. If we have 1 redundant, we remove 1. If we have 3 redundant, we remove 3. Okay, this is 5 reaction, we remove 2. And always remember, when we remove, we have to remain the stable and determinate condition. Stable ni based on the support. So kalau in frame ni to get stability, okay, and equilibrium, so we must remain at least 1 pin 1 roller. 1 pin 1 roller. Okay, or we can also remove 1 pin because 1 fix also stable structure. Okay, and in two redundant system like this, we will have what we call as possible primary structure. 1 redundant, there are 2 possible primary structure. 2 redundant, we have 3 possible primary structure. Okay, we will start with identify redundant. So we have, okay, 2 redundant means that we have R1, we have R2. We have R1, we have R2. R1, we have R1, R1. Okay. We have 3 possible primary structure means it is like this. For example, okay, let's say okay, this is the frame. This is the frame. Okay. Possibility number 1. Possibility number 1. Possibility number 1. Fix. Remove pin. Okay. Fix remove pin means that we remove CX. We remove CY. Okay. Okay. This is the first option. The first we call it as possible primary structure. This is primary structure after removing CX and CY. This is primary structure after removing CX and CY. Okay, this after removing CX and CY. This is the first possibility. Okay, second possibility. Second possibility, okay, we remove 1 from A, 1 from C. Remove 1 from fix, fix become pin. Remove 1 from pin, pin become roller. This is primary frame. Option number 2. Option number 2. Okay, this is when we remove MA and C X. Okay. And we can
Okay,
have
Doctor.
option number 3. Option number 3, we have frame. We have frame. Remove 2 from support A. Remove 2 from support A. 3, remove 1, become pin. Remove another one, become roller. So roller here, remain pin at C. So this is option number 3. Option number 3 means that we remove MA, we remove A, remove apa? AX. AX. So we have 3 possibility. So these three are called as what? Possible primary frame of primary structure. These 3. Okay, possible primary structure. Possible primary structure. So normally this is the first question in test or in final exam. Okay, you are asked to sketch possible primary structure. So if you are asking to sketch or draw possible primary structure, you have to give like this. Okay. Then number one, when we remove pin, okay, remain fixed at A. So it is stable, it is determinate. Okay. And then number 2, we remove 1 from pin, 1 from A, 1 from C. Okay. So in the system, there are 1 pin, 1 roller. 1 pin, 1 roller is stable structure. Stable and determinate. Okay. So this is option number 2, possibility number 2. And number 3, we remain pin at C, but we remove 2 from fixed. Okay, so it remain 2 support, 1 pin, 1 roller as well. So we get this as the third possibility. Normally, redundant will be given in the question, and actually we can choose to solve to analyze this frame by choosing only one. You don't need to do all option. You just need to choose one. Okay, choose one. So let's say we choose 3 as possibility number 3. Okay, means that we will choose MA and AX as the redundant. So back to this. So R1 is MA. R1 is MA. MA. And R2. R2. R2 is AX. AX. Okay. So now, normally for 2 redundant, we will use numbering instead of using ABC. Okay. So start from now, we change our direction. Okay. Instead of using ABC, we choose to use numbering. Okay. So redundant number 1, MA means that the redundant position is A. Okay. But this is for moment. Okay. And redundant number 2, AX. So both are at the same location, but one is moment, one is force, horizontal force. Okay. So from this, we should straight away write the equation, the standard one, compatibility equation. We have the standard form. Two redundant means we will have 2 by 2. Okay, 2 by 2 matrix, flexibility matrix. Okay, we will start with the primary system. The primary system because we want equation equal to 0. Okay, that is why we start with primary. Okay, so there are two displacement in primary system. Two displacement in primary system. Okay, plus 4 displacement in two redundant system. Okay, we have two redundant. And this is equal to 0. Displacement in actual system, actual frame. Okay, so this is equal to 0, 0. Okay, these two are displacement in primary. So look at the redundant. Moment is the redundant, so the first one will be theta. Okay, theta, and instead of putting A, because both are A, if we use A, so how? Kan? So we have to change to numbering 1, not. Okay, not is symbol for primary system. By looking at the symbol, we know that this is displacement, rotational displacement. Okay, position redundant number 1 in primary system. Okay, and number 2 refers to redundant number 2. It is AX, it is force, so it is delta. Delta, this is number 2, right? Number 2, so it becomes 2 naught. Okay. Okay, next is flexibility matrix. Flexibility matrix 2 by 2 because of 2 redundant. Okay, and it must follow matrix characteristic, the position 1, 1, 1, 2, 2, 1, 2, 2. The matrix characteristic. So all F. Okay. Okay, F. So this is flexibility matrix 2 by 2. 2 by 2. So follow the matrix characteristic, the position. It is 1, 1. Then 1, 2. Then 2, 1. Then 2, 2. Okay, it is just matrix. Okay, and we have to times with redundant. Redundant 1, redundant 2. Redundant 1 is MA. MA. Redundant 2 is AX. Okay, so this is actually the compatibility equation. Okay, compatibility equation which will guide us what to do next. Okay, because inside this there are 6 displacement. Inside this there are 6 displacement. 1, 2, 3, 4, 5, 6. 6 displacement. 3 system. There are 2 redundant position. 2 redundant position in each system. That's why total are 6. Total 6. So 6 displacement. 2 at redundant at primary. 2 at primary. And then 2 in redundant number 1, redundant MA applied, and another 2 at redundant number 2, redundant AX applied. Okay? Okay, from the symbol that we use, okay, look at the notation. So we find that inside all these 6 matrix, there are 0, 1, 2. Kan? 0, 1, 2. 0, 1, 2. 0 is always for primary system. the not symbol, the zero symbol, not symbol is for the primary system. Okay, 1 for redundant number 1, 2 for redundant number 2. Okay, so from this we know that we already know that the displacement formula. Okay, so I don't want to type the formula. Okay, what I want to explain is the three symbol, the three notation that we use inside this displacement. It is not 0, 1, 2, representing M0, M1, M2, M0, M1, M2, and M0 is the moment equation. M0 is the moment equation. If we analyze thrust, the equation, the compatibility equation is same, but we are not going to write moment equation because moment equation is for beam and frame. Thrust we use N. We calculate N for thrust. Okay, so M0 is moment equation for primary frame. And then we have M1 is the moment equation for redundant number 1. What is redundant number 1? For redundant MA. Applied. Okay, MA applied, and M2 is the moment equation for redundant AX. Applied. Okay. So what are the three systems that we are going to analyze? The three determinate system. The first one is primary frame. Okay, the first system is primary frame. Second one, redundant MA applied, redundant 1. The third system, redundant AX applied. Okay, it means that for this three system, it must have the same type of frame with same support system. Okay, these three frame are determinate frame with the same support. Okay, same support. Okay, and the difference is only due to loading. Okay, so you have to understand the characteristic of each one. Okay, we get this from principle of superposition. Okay, the one that we derived in beam last week. Okay, we have primary frame, redundant number 1, redundant number 2. So both, not both, these three are the same frame. These three must be the same. Okay, these three must be the same. Okay, roller at A, pin at C. Roller at A, pin at C. Ini pin kan? Ini roller. Okay, so we have 3 frame like this. We have 3 frame like this. 3 frame. Three. Three frame like this. Okay, 3 frame. The same frame. Same support. Okay. Number 1 is to calculate M0. Number 2 is to calculate M1. Number 3 is to calculate M2. Okay. So yang ni for M. This is for M0. Means this is primary frame. From the label, we know that this is primary frame. If you want to label, it's up to you. Okay. The second one, M1. Redundant number 1. Okay, it is belong to redundant number 1. And M2 belong to redundant number 2. The third system. Okay. In primary system, we have to remain all external loading. Okay, we have 15 and 10. Okay, 15. Okay, we assume that 15 is subjected at the center. Okay, we assume that this 15. Okay. Because I do not copy the instruction, right? Okay, assume that this 15 is subjected at the center. AB 3EI, BC 2EI. It is not constant. Okay. So 15 and 10, 15 and 10. So this. Fifteen kan? 15. Okay. This is WDL. This one is 15 kilonewton. 10, 10 kilonewton per meter. Okay, this is 3 meter, 6 meter, 3 meter. Okay. Okay, assume that the 15 is subjected at the center, 3 meter, 3 meter. Okay, label A, B, C, D. Okay, A, B, C, right? C. But at 15 kilonewton, we have to add another point. Okay, D. Okay, so this is primary frame. This is determinate and we can analyze, we can calculate reaction, we can write moment equation. Okay, move to diagram number 2. This is redundant MA applied. This is redundant MA applied. Okay, remain support and remain label A, B, C, D. Remain. So we have A, B, C, D. Okay. And this is a frame, this is a determinate frame subjected to this is redundant MA applied. So we have to apply It is just like virtual system. A unit apply what?
One.
Do not put unit because it is 1 times MA and unit belong to MA. MA we remove, right? Okay, we remove MA. Okay, that's all. That's all for redundant number 1. Okay, move to the next diagram. This is M2 for redundant number 2. What is redundant number 2? AX applied. AX applied. Means that we have to apply, yes, a unit value. A unit value. Remain the label. Remain the label A, B, C, D. Okay, like this. We have 3 systems. We have 3 systems. Only primary system have all external loading. Redundant system is a system subjected to a unit value of redundant. Okay, that is why here we times back with redundant. Okay, everything inside redundant system we must times with the redundant. Okay, means F cannot stand alone macam delta 1 node and delta 2 node. Delta 1 node, delta 2 node stand alone. Okay, stand alone. Sebab delta 2 node and delta 1 node, 1 node and 2 node ni, theta 1 node and theta 2, delta 2 node ni, refers to this frame, primary system. In primary system, dia ada loading kan? Loading ada unit. Okay, jadi displacement in the primary system, dia ada unit. But not for F. Not for F. Dia ada unit bila dia bergabung dengan redundant. Now we divide. Kita pisahkan ya redundant daripada F tu kan. So F cannot stand alone. Actually semua ni delta dengan theta. Okay. F11 kali MA is actually theta. Theta 11. Okay. But because we want to calculate redundant, right? That is why we have to apply like this. Okay. Dua-dua ni gabungan dia jadi gabungan dua ni become force displacement. Force displacement principle. Kat sini dia ada satu principle yang kita apply yang nama dia force displacement. Force displacement principle. Sebab tu kalau tengok kat sini, MA dengan AX ni force. F ni displacement. F ni kan displacement. F ni displacement. Okay, so yang ni force displacement principle. So inside compatibility equation tu ada satu principle yang kita apply. Okay, that is force displacement. Okay, because our aim is to calculate redundant. Okay, redundant. So F ni cannot stand alone. Dia tak boleh F11, F12, F1, F22 only. Okay, dia mesti pair back with redundant. Okay, and unit tak ada pada F tapi ada pada redundant. Okay, bila combine baru ada unit lah. Okay, now when we analyze redundant system, do not put any unit. Okay, so that's why saya tulis sini a unit value. Sini pun a unit value. Okay, a unit value. Unit dia ada pada MA and AX. Okay. So now, what we need to do with these three determinate frame? Kenapa kita buat yang ni? Kenapa kita buat step ni? Ya? Nak cari moment equation. Okay, moment equation. So there are three system. Okay, there are three section. AD, DB, BC. Three section. Okay, so all moment equation we tabulate. Okay, into table. But before that, we have to write the moment equation. What we need to have first? Before calculation, reaction. Means that we calculate reaction because with reaction we can write moment equation. Okay, because what we want is moment equation. Nampak tak dia punya flow? Start from reaction, follow reaction first, then moment equation, then displacement. Okay, this is the three important things in structural analysis. Okay, so calculate reaction for all these frame. Okay, take about 5 minutes to calculate reaction. We start with the primary frame. Okay, please calculate reaction. Mana calculation? Ingat lagi calculation. Last kan? Rasa senang ke susah? Explain. Apa yang saya letak dalam OneNote tu ada banyak version daripada banyak orang yang tulis. Daripada banyak compilation lah, bukan orang tulis semua daripada buku teks Tigler tu. Okay, dan bila nota tu jadi based on interpretation setiap orang yang menulis balik tu lah kan. So, kalau you rasa tak boleh faham, just take question, dia tengok soalan dan try buat jawapan, solution. And check dengan method yang belajar dalam kelas ni. Okay, and I think and I believe this is the easiest. Okay, so that you don't need to remember all the formula, right? Kalau you kalau you hafal, start from bottom, you akan hafal. One day lupa kan? So that is why I always say that everything you kena set, start daripada A. Yang saya kata backward tu kan? Okay? Always statement. Yang lain nanti boleh datang kelas. Kelas petang-petang tak ada orang pakai. Okay. Kena set. Always begin with the end in mind. Sama macam saya cakap kan? Kita kena tengok apa kita punya target, reaction. Kan? The target, our target is reaction. Reaction ada 5. 5 cannot calculate 5 directly. So we have to apply flexibility method or use compatibility equation. So inside compatibility equation tu, apa kita kena buat? Moment equation. Nak dapat moment equation, apa kena buat? Reaction. And don't take too much time to calculate reaction. Okay? Because reaction is not your aim. This reaction to be part of solution. Do you get the same reaction? Yang online, what do you get for the reaction in primary frame? What do you get? AY, CX, CY. What do you get? Lambat you siapkan, lambat balik. Cepat. Saya pun nak balik cepat. CX. What is CX?
Negative 50.
CX, CY. CX berapa?
Negative 15.
Negative 15 for CX or CY?
CX.
Yelah 15 kan. CY
52.5.
52.5. Berapa? 22.5. 22.5. This is 15. Positive 22.5. Yang ni. AY? $37.5 plus 22.5. Do you get 60? Okay. Okay. Ada. Okay. So settle reaction in primary frame. Okay, what is C, Y and AY? CX0. CX0, CY and AY. What is CX, what is CY? Berapa? 0.167. Ini negatif. Okay? Okay, online yang join online, do you get the same? Do you get the same for AX, AY and CY? Do you get the same?
Yes, madam.
Okay. Okay, what about redundant number 2? AX of course is 1 in opposite direction. Okay, what is AY and CY? AY 1. What do you get? 1. Okay, yang online dapat apa? AY dengan CY?
1.
1. 1 yang AY 1 ke negative 1?
1.
A1? 1. 1. Yang ni macam ni. Yang ni negative 1. Sebab dia dua-dua 6 meter. Okay. Okay, we have 3 cutting section. Dah ada reaction now. We will write the moment equation. Okay, we will have 3 section. We have 3 section. Remain the same section in all system. Okay, kita punya reference is the primary system. Is in primary, we have 3 cutting section. We have to remain the 3 cutting section in redundant system. Then only we can integrate together. Okay, we have 3 cutting section. Okay, and we summarize in the table. We summarize in the table. Okay, remember origin. Member origin apa lagi? Limit. So we have 3 column for M0, M1, M2. We have 3 column for M0, M1, M2. M naught, M1, M2. Three cutting section. Three cutting section. Okay. M naught, M1, M2. Okay. So list all the cutting section. We have A, AD. Second one, DB, BC. Okay, for cutting number 1, AD, origin A. DB origin, choose the easiest section. The shortest and the easiest. Kalau you pilih B tu, not the easiest. The hardest. It can be A, it can be D. Okay. We can choose A as well. Okay. For BC, C. Okay. When A is origin, A in member AD, for the first cutting section, what is the limit? 0 to 3. 0 to 3. Okay. For cutting number 2, DB, origin A, limit 3,
3, 6.
3, 6. Okay, 3, 6. BC, 0, 6. Okay. Okay, M naught. For primary system. M naught for primary system. Okay, moment direction first. Okay, AD moment clockwise or anti-clockwise? Clockwise or counterclockwise? For AD. Counter. Okay. DB. Origin A. Clockwise or counterclockwise? Counter. Okay. BC origin C. Clockwise or counterclockwise? Clockwise. Okay. So same goes to the other system. Okay. Okay, now, what is the first moment equation? M naught for AD? What is the first one? 0. The first one is 0. The first one is 0. Okay. Move to second section, DB. DB, origin A. DB, origin A. What is the equation? DB, 15 here, right? 15. Moment. Moment. This is X because A as origin. This is 3 meter. So the shortest distance to? This is X minus 3. Okay. So what do you get? This is M naught. Okay. Negative M naught. Okay. Negative M naught Negative 15 x
X minus 3.
x minus 3. So m naught equal to negative 15x plus 45. Okay? It's fine. Negatif. Tak boleh baca tu. Skrin hilang. Tarik. Negative 15x plus 45. 45. Okay, what about this? What about this? UDL 22.5. Moment M naught. You see what? 10. So X. This is X. So M naught. M naught. Minus 22.5X lagi. Plus 5X square. Equal 0. So M naught equal to 22.5 x minus 5x square. Okay. $22.5. This lah. Okay, 22.5. X. 22.5x. 22.5x minus 5x square. 5x square. Okay. M1. 1. Opposite. So positive. Okay, 1. For cutting number 2. Cutting number 2. 1 also. 1 also. Cutting number 3. 0. BC. VC? What? 0.167?
X.
M2. Is it 1? M2? X or negative X? X or negative X? Negative X. For both. Negative X. And this one? X or negative X? X or negative X? X or negative X?
X.
Is it X? Moment. One like this. One mana? One bawah. One bawah. Mana dia tadi? Okay, one bawah. Okay, one bawah. One bawah negative X. Negative X. Okay, negative X. Okay, yang online, okay? Can follow or not?
Okay, madam.
Okay. So, what next? What next? Okay. Right, no. Calculate displacement, 6 displacement. Okay. Once we get all moment equation, okay, we can calculate displacement. We can calculate displacement. The first one is theta 1 naught. Theta. Mana theta? Theta 1 naught. And this is equal to 1 over EI. 1 over EI. 1 over EI. Integrate. Okay, integrate M1 M naught dx. Okay, from 0 to L. From 0 to L. Okay, sekejap. Okay. M, 2M, M1, and M naught. Okay. So this is equal to, okay. Don't forget we have unconstant. We have 3 and 2. 3 and 2. 3 for AB and 2 for BC. Okay. So the first one is 1 over 3 dulu kan tadi? 3. 1 over 3 EI. Cutting number 1 A to D. Okay, it is 0 to 3. 0 to 3. It is 1 and 0. It is 1 and 0. Okay. Plus 1 over 3 EI from from 3 to 6. Okay, from 3 to 6, it is 1 and this. Okay, and plus another one. Plus one over 2 EI from 0 to 6. Okay, it is 0.167x times with this. Remove ni. Okay, please solve this. Calculate this. Okay, please solve this. What do you get? Total. Total dah. Negatif. Sama tak? 3.75. Yang online, what do you get? Total. Negatif. 3 point. Negatif. Betul ke? Double check, double check. Yang online, cuba check. Okay, please check. All of you, please check. Total. Okay, yang online berapa dapat? Okay, the first integration is 0. The second integration equal to? The second integration equal to? We get negative 67.5 divided by 3. And another one is okay, another one is 0. Tak letak kurungan. Saya letak kurungan tak? Letak kurungan. From 0 to 6. Dapat apa yang ni? Divide by yang ni? Integration yang number yang ni. Yang ni. Yang ni. Ni, this one.
Saya dapat 0. Total.
Dapat 0. Tak, yang first dapat ni tadi. 67.5 divided by 3 kan? 67.5 divided by 3 equal to 22 point. It is negative 22.5. Negative 22.5. Total. Okay? Betul Okay. Okay, so this is theta 1 node. Theta 1 node. Tak ada apa, dia just for the answer for this. Mana satu? Yang tengah-tengah ni. Kalau nak refer nantilah kan. Okay. Okay. Okay, next is delta. Delta 2 node. It is delta 2 node equal to, okay, delta 2 node is Okay, saya terus tulis equation ya. Yang ni. It is 2 pula. Negative x. Negative x. 2 not. Negative x and 0, right? Okay, plus. Actually tak payah tulis, tak tulis jawapan je. Ini nak tunjuk step. Okay. Tak payah tulis panjang-panjang tu. Cukup just use, kan dah ada equation kat dalam table. Terus tulis jawapan. Tulis jawapan, yes. No need to rewrite the equation inside the formula. No need to do that. Okay. Ni nak tunjuk proses. Okay, so table terus bagi displacement, 6 displacement. Okay, second one is this. Okay, it is negative x. Negative x dengan negative x dengan negative 15x plus 45. 2 not. Okay, 2 not kan? 2 not yang ni. 2 not. Kan tadi 1 not sebab tu 1 ni. Okay, so now 2 not. 2 not. Negative x and negative 15x plus 45. Okay, plus. Okay, this. Okay, we have negative x. Negative x and 22.5x minus 5x square. Okay, now please calculate this. Okay, for the second integration, the first integration to 0. The second integration is the second integration. The first is 337.5. Is it right? Divide by what? Divide by 3. Divide by 3, right? Okay, another one. Okay, another one is 0 juga. 0. So what we get is 337 positive. Yeah, 112.5. Over EI. EI. I 112.5. Okay. 112.5. Baru dapat 2 displacement. Ada lagi 3 lah. Dia lagi 4. Tapi ada 2 tu sama kan? Okay. So F11. F11 Okay, it is F11 equal to F11 is 1 3EI integrate 0 to 3. 0 to 3, 1 1 kan? It is 1 square dx. Okay. Plus limit different. Limit different. This is 3 to 6. Okay, 1 over 2 EI. 0 to 6. 6. 1 juga 0.167. 0.167x. Kan? 0.167x. 167x. Okay. So please calculate this. Okay, over EI. Over EI. The answer is 2.08. 8. This one. Okay, yang online?
Okay, Doctor.
Is it 2.08?
Yes.
8. 8.012. So which one is correct? Yang baru? Okay, F11, what is the answer? 3 over EI. Okay, yang join online, what is the answer for F11? Do you get 3 as well? You get 3.
Ya, doktor. Betul.
Betul eh? Okay, so do the same until you get all F11, F12, F21, F21, F12. Do it once only. Kan, same. Because it is symmetry matrix, so F22. So continue all. Have you calculated F12 and F22? Not yet. You nak continue this until the end or you nak stop? Stop nanti next class baru buka balik. Hah? Boleh macam mana tu? Betul buat sendiri. Try buat sendiri. Tengok video yang tadi. Yang ada satu dah ada full solution. Itu dah ada full solution tapi one redundant. Yang tadi pun saya explain sampai habis tapi tak calculate sampai habis lah. Okay, you please complete this because you have remaining, saya tulis apa yang you have to continue. Okay, so you have remaining F12 which is equal to F21. F21 and then you have F22. Okay, tak share, sorry. Tak apa. Adik boleh je share. Kejap. Okay. Okay, so you have to continue to calculate F11 which is equal to F21. Lepas tu calculate F22. So dah dapat 6, so substitute into this equation. Okay, substitute into this. Okay, so you will get compatibility equation in terms of EI. And when you solve, only you cancel EI. Because compatibility equation is displacement. Displacement is when it is divided by EI. Okay, so when you write the compatibility equation, mesti letak 1 over EI outside the bracket. Okay, and then solve. This is actually equivalent to 2 simultaneous equation. Okay, rearrange balik lah. This is equal to 2 simultaneous equation. Okay, so you kena bawa macam biasa lah. Kena bring this to the other side, right? 2 simultaneous equation. You will get something like this. You will get equation macam ni. For example, you get tadi apa nilai dia? 22.5 tadi tu. Apa nilai dia tadi? -22.5 ke tadi? Negative 22.5. The next value? 112.5. 112.5. So this is 1 over EI plus 1 over EI. This one. Times with redundant, right? Equal to 0. So to solve this, you have to bring this. Okay, bring this to the other side. It will equal to, so bila dah solve, dia jadi macam ni. XY equal to 2 simultaneous equation. So nilai ni A1, B1, C1. Dalam calculator simultaneous equation kan? Simultaneous equation A2, B2, C2. There you will get X and Y equivalent to redundant 1, redundant 2. Solve using simultaneous equation. It is 2 simultaneous equation. You get what I mean? Okay, ada banyak video yang saya dah ada example ni. Yes. Okay, please watch. Please complete this. So yang ni you have to complete sampai you dapat all 5 unknown reaction. Okay, get 5 unknown reaction. After that you have to please put into your folder, your own folder. Letak kat sini under homework. Boleh? Under homework nanti you siapkan, you snap picture as usual lah kan. Snap picture and please add into this. Okay, so I want everybody to solve until the end. Kalau tak solve, rasa macam senang tapi bila nak solve betul-betul, tak boleh. Okay. So dia you kena practice je. This is just mathematical, remaining is mathematical calculation, simultaneous equation. Okay, saya ada buat dalam satu video dalam group mana tak ingat. Saya ada buat example yang saya tunjuk the other way to calculate remaining reaction is not by using equilibrium equation, but because we have two options. We can calculate remaining 3 unknown reaction using equilibrium equation macam biasa, or we can also use principle of superposition, which is easier than using equilibrium equation. Video pagi tadi pun ada untuk one redundant punya example, and ada one group punya kelas last week tak ingat. Okay, yang ada solution tu saya buat in full sampai habis. So please watch. So yang ni kena completekan everyone. Yang online pun sama, kena completekan and put into your class notebook under homework folder. So you just create add page and put name frame 2 lah, frame 2 hari ni punya kan. Okay, and saya nak tengok yang last part tu. Okay. Is it okay? Dah pukul 6.20. Belum asar lagi. Okay, I think that's all for this session. Okay, I hope everyone understand. Do you understand? Okay, because we have for the next session we will analyze You are going to learn about support settlement in beam and in frame. Okay, actually macam ni juga solution juga. Cumanya akan ada additional effect lah, support settlement yang kita akan include in actual system beam and frame. Masih lagi sama proses ni, cuma akan beza dekat one portion only. Okay, make sure at the end of this week you dah boleh buat all beam and frame question. Because next week we are going to learn truss. Okay, we are going to do truss, and truss normally the difficult part is the member forces. So make sure you understand very well. Okay, please do regular exercise. Okay, do regular exercise. Lepas tu the best is buat latihan, submit lah. Submit letak dalam folder tadi tu. Okay, so that I can check. And don't forget to upload video. Nanti saya akan reopen the due date. Okay, please everyone must to submit the video. Okay, so that's all for today's session. Thank you very much.
Doktor,
Ya?
kalau dah buat homework tu, nak kena bagi tahu doktor dekat WhatsApp ke dekat mana nak?
Okay, macam ni. Saya akan assign through Teams, so you will get notification. So once you upload, please hand in. So bila you hand in, I will get notification. Okay? Tak payahlah everyone message kan? So saya akan assign as assignment untuk you submit. Kalau you nak snap last page pun okey. Tapi saya nak tengok everyone ada calculation tu lah. Okay, tapi kalau boleh in class notebook tu kan, you boleh letak all your exercises kat situ. So that in the future you nak refer senang kan. Rather than duduk dalam kertas nanti hilang mana-mana kan. So every exercise that you do, snap, okay, and then upload. And then kalau you nak actually yang saya buat ni, yang saya buat dalam content library ni, kalau you nak masuk your own folder pun boleh. Kalau nak saya masukkan dalam your folder, ini dalam my folder. That's why you hanya boleh view. If you need this for you to not only view, you nak contoh-contoh, you nak highlight apa semua kan, just tell me, saya akan distribute to you. Okay, by request lah. Okay, by request. Apa nak, just inform. Kalau semua nak, saya just sekali blast je lah. Okay, kalau individu nak, mungkin ada yang tak perlu, dia just cukup tengok dekat dalam ni kan. Saya boleh distribute this and dia akan masuk in every folder lah. In student folder. Okay, kalau you nak, just tell me lah. Okay, saya dah tutup tapi yang dalam kelas boleh tengok lah. Okay, so ada lagi soalan? Ada lagi?
Tak ada doktor.
Tak ada, doktor.
Okay, make sure you don't have choices, you have to do exercise. That is the only way to understand and to success. Okay, regular exercise. Dia akan jadi senang kalau you selalu buat, because you tak sempat nak lupa pun. Kan, benda tu dah jadi habit bila you selalu buat. And bila you understand, not only understand, bila you understand, you can analyze, you can apa lagi? Analyze, lepas tu evaluate kan. So benda tu kalau you dah familiar, dia akan jadi senang lah. Dia dah jadi habit. Tapi kalau you simpan, ada part yang tak faham, tak take opportunity untuk tanya, lepas tu lupa, at the end of semester buka balik, you macam tengok benda ni for first time. Masa tu yang akan jadi difficult. Okay, so do as habit. Benda ni jadikan dia habit. Okay, sebab benda ni inflexibility method ni actually bukan the new thing. The new thing inside this is only the application. Kan? Tapi overall calculation semua yang you dah pernah buat before this, right? You dah pernah buat masa solid mechanic, kan? Dah pernah buat masa determinate structure. So you just need to revise. Okay, revise. Make sure moment equation, reaction moment equation tu do it correctly and carefully. Sebab kat situ yang selalu student sangkut. Dia memang I believe everyone understand what is flexibility method. Tetapi without the right reaction, without the right moment equation, of course you will not get the right answer. Okay, so benda tu kena familiar. Kalau you tak familiar, memang kita akan ada possibility buat mistake. Okay, so to avoid mistake, careless mistake tu memang kena banyak latihan. Okay, so that's all for this session. InsyaAllah we will meet again in the next session hari Khamis. Okay, so thank you. Please don't forget to, dah lepas dah time kan, you have to tick your attendance ya in the future in every session. Okay, because kita punya kelas memang online, so attendance semua daripada sana. Okay, so thank you very much. We close this session with Tasbih Kifarah and Surah Wal-As.
Madam,
Ya.